Well. Hello and welcome to this update, Apache Pinot 2024 roadmap update. Today, I will be your host and also my friend of mine and also somehow my boss, Tim Berland, also will be your host today. I'm Victor
Thanks
Gamov.
for
I
having me
work
on,
as
Victor.
yes.
Yeah.
Thank you for
Oh, I stepped on you. You're
joining
Victor Gamoff, and who am I again?
Tim Berland from
There you
Start.
go. We're
We
here.
will be your host today, so we will be responsible for entertaining and introducing guests and making sure that they're not running all the time because there will be massive amount of information that we want to share and everyone wants to like talk all the things about. So um and the thing is that I believe we also run of the some of the limits, which is good things. Before we start, let's test our chats and let's see how our thing is working. If you're watching us live, if you can see us, if you can hear us, write
Whether you're on LinkedIn, YouTube, wherever you are, chat with
all
us.
right.
Also, I'd like to hear from some folks confirming the audio. So if you're chatting, also let us know you hear us. Everything sounds good.
All right. So we do see some folks who asking if the people joining us at the Real Time Analytics Summit next week. Okay.
Yes, Victor and I will be at the Real Time Analytics Summit next week.
Okay. So interesting because people using chat in LinkedIn not for the stream, but for the troubleshooting some problems. It's kind of funny, but people use if you are a speaker, use the private chat. It's for our speakers, and for people who are joining us on YouTube or Twitter or LinkedIn, just tell us where you're coming from. Where's home for you? For example, I'm joining from East Coast in New Jersey.
I am at Startree headquarters in Mountain View, California.
Right. Okay. So we do have a few folks joining us here. Okay. Cool. All right. LinkedIn works. So at least we see LinkedIn works. All right, Tim.
Yes.
I think it's time to bring in our esteemed speakers.
Let's show some slides. I want to real quickly give a little bit of context before we kick off. So, next slide, Victor. Is that you?
You can also drive, I believe so.
Oh,
but
yeah.
you can be our Larry from Oracle and ask him to do next slide, please.
I take that personally.
Yes.
All right. There's a lot to cover today. We're going to hear about updates from across the Pinot community, covering things like improvements to the multi-stage engine, improvements to SQL compliance, because Pinot is not yet full ANSI SQL, but we're chipping away at that. We're going to look at things there. Improvements to query execution, like some pagination stuff and some new functions that are being added. Upserts will never be done improving. There's always more to do there. The exciting topic of enterprise readiness, which is one of those things that sounds lame when you say it, right? But it is incredibly important for the success of the project.
As long as you're not using words like a synergy and business value, it's fine.
Exactly. And not on this call. This is not where we do that. But yeah, if the thing can't be broadly deployed in large scale enterprises, it's going to get traction and win long term. So that's important. Improvements to indexing, storage, ingestion, all across the board. Everybody, reminder to the presenters, you've got 1 minute per slide. Now, when we did this last year, I was a little heavy-handed. I'm not gonna tell you to shut up if you go over your minute. Please police yourself. So in other words, there's a lot of detail on these slides, okay? This is being recorded. It's going to be available after the fact. You will be able to study the slides in more detail because there's a lot there. Presenters, don't feel like you're obligated to cover the whole thing. Just give us the quick summary so we can get through it all. All right. With that.
Yeah, and I'm playing with chat and see a lot of things going on. So a little bit statistics right now. So 22 people watching us in the X platform, or formerly known as Twitter.
Formerly known as Twitter. Okay.
Yeah, we have a few people watching us on the YouTube and a lot of stuff going on in LinkedIn. Please continue.
LinkedIn is the new Twitter, as they say. So
yeah, exactly.
All right. Let's jump in. Jackie, unmute. Tell us about
Jackie, welcome to the show.
Hi. Yeah. Thanks, Victor and team. So this is Jackie. I'm joining from StarTree headquarters at Mountain View. And I want to kick off the show by introducing one of the most important. Oh, sorry, I cannot see the
Okay.
slides.
Yeah, I just wanted to show your face to our audience so you can introduce yourself, like why you are, so important for this project and why you're talking about these things. Always don't be shy to talking about your stuff. Why you important for this community.
I mean, yeah. So I have been working on this project for like over 8 years. So it's definitely like my favorite, and I'm still very passionate about it. So that's
Right.
why I want to introduce I would say the biggest milestone we want to achieve this year is enabling V2 by default. So let me explain what this means. So right now, like since release 1.0, the major release, we introduced the multi-stage engine. And then it has been running for a while, and then we want to start the effort of replacing the single stage engine with multi-stage engine. So what does that mean? That means all the queries supported by single stage engine should be supported by multi-stage engine. But there are certain caveats of the single stage engine where it's not really SQL compliant. So certain query rewrite need to be performed because we want to make multi-stage engine SQL compliant. And so we will provide a migration tool, and then we also need to support multi-value because multi-value itself is not a standard SQL feature, but it's very important. And then some requirements. So V1 is like super high performance. So V2, we know there will be certain overhead, but the overhead should be minimal. Like query planning should take definitely like some millisecond, and then it shouldn't cause any broker hotspot. And then we also want to provide the same level of robustness and observability, the same level as single stage in the multi-stage. So this is a very wide topic and then a big scope. So I would like to welcome the whole community to contribute on this feature. Yeah, thanks.
Do you want also me to advance your slides as well?
Yeah. So
I guess
I'm done with that.
That's only choice.
Yeah, this one is for Gonzalo, the previous one.
Okay.
Are we going to run? I think we'll run slide by slide, right? So
okay, yeah, that's fine. I can bring the Gonzalo then. So we're gonna see, folks. We're doing this first time. I'm super excited to have so many guests. Usually I have like a 2 or 3 guests. Now I'm super overwhelmed. So bear with us in terms of how we're gonna switching. We will be better on this one. Gonzalo, welcome to the show. Tell us like in few words about yourself.
Yeah, I'm been working on StarTree for a couple of years, and I'm been recently promoted as Apache Pinot committer. So and I mainly focus on right now I'm gonna be mainly focused on multi-stage. So yeah, I'm gonna tell you a little bit about that. I think it's important. We think that it's important in order to use multi-stage as the main query engine in Pinot. It's important to have a system that is as easy to do as possible. There are some gaps that we still need to improve before turning this as the default engine. One of these is something that a lot of people have been requesting, which is having the ability to explain to show the indexes that we are using when you explain a query. Okay, there are also some things that can be improved in the documentation. You have a list there, but basically it's like improving the stats and showing how to use that and giving you information to feel, empowered to do all your queries without having to, be blocked and stuff. So that's a super important thing we want to improve. And with that, it comes some other improvements like having better error messages and also improving the downtime upgrades, because right now there may be some issues if you are running V2 queries or multi-stage queries and you are just upgrading your system.
All right, so we're going to the next slide. And this, again, Jackie. Thank you so much, Gonzalo. We're bringing back Jackie to talk about another exciting topics, performance. Everyone loves to talk about performance.
Yeah, actually, this would be a follow-up slide from the previous topic. Like because that's, as I said, that's a very broad topic. So in order to replace single-stage engine, we need to achieve the same level of performance, but much more flexibility from multi-stage engine. So let me summarize what we have already done in the past year to improve the performance. So we like did a lot of improvements in like semi-join, collocated join, partition, parallel execution, and query plan serialization. So for one use case, with all these improvements, we saw like latency dropped from close to 1 minute because we are joining billions of rows, and then we are able to achieve sub-second latency, which is like starting off the product, that's unbelievable, but we achieved that. So now for this
take
year,
that. And the people are always complaining about the Java being slow, right? So take that. Java is still kills it.
yes. So
That's scale.
imagine joining billions of rows. Billions as in like there are like billions of rows on one side, and I don't remember, like more than 100 million rows on the other side, and then Pinot join all of them at runtime below 1 second. So going forward this year, we want to keep improving the following topics like query stats, optimization rules, group by join, window function, thread management, and table spool. So each of them is I would say like mid to large size project. So again, I would like to ask people from community, like pick some topic you're interested in and then contribute.
Yep.
Thanks.
The next one is SQL compliance. I think this is a very important question to solve right now. Like how you pronounce, is it SQL, SQL, squirrel? Like what's the Gonzalo? It's your take on how you pronounce it.
Well, I'm from Spain, so we usually pronounce like SQL, which is like horrible. But yeah, I'm not used to call it SQL right now. Yeah.
I probably will use this as a snippet to share on social media how to pronounce this, because it's gonna be super viral, and yeah, we're gonna roll with this.
Yeah,
I see the team wants to add something.
It has to be a sequel if you're a native Spanish speaker. You can't start with this, so that's a good point.
Yeah, it's impossible for us. Yeah, one of the things we want to improve here is the null handling support. That's a pretty complex topic right now in Pinot, and we want to make it easier to use. And in fact, the basic idea is that we don't want to turn it on by default. Right now in Pinot, you have to actually say that you want to store nulls in your tables, and you have to then say again that you want to use those nulls at query time. And our objective is to just work like you would expect that, which is like to say, hey, this column has null, this other column doesn't have them, and automatically the query engine is going to understand that and is going to use them. The main reason we are not doing that right now is because there are some performance implications when we turn on null handling at query time, but we are going to deal with them, and ideally we are going to enable that by default. This
And
for sure.
it's again the $1 billion problem already hitting us from everywhere. So null support, or like how we can handle nulls, is a very, very interesting problem. How to people, dealing with data. Jackie will tell us a little bit about. I'm super excited about this. Kind of in the way how the stream processing and Kafka becomes like the language, the Postgres become language for all this like data systems, like wire protocol. Jackie, can you talk a little bit about this?
Yeah, so actually, people, especially like advanced user or like people from SQL world, might already realize a lot of like things that's running differently in single stage engine, where for example, like function polymorphism. Like right now, if we run min-max in single stage engine, it always returns double. And then if you feed a string value into this function, so we'll try to parse it as double, meaning it's fixed type. It's like, it doesn't care what's the input type, and then it always executes it as double. So similarly for other things. So in the multi-stage engine, we want to shift it to like full PostgreSQL compliance, meaning taking like min-max on integer column should return int, and we should support string min-max, which should return string. Similarly for a strong type, like in Pinot single stage engine, like column equals 1, 2, 3 integer has no difference as a column equals to string literal 1, 2, 3. But actually, if you compare, this is not a very good example because literal 1, 2, 3 is unknown type, so it can cast. But let's say, for example, bytes has to be strong typed, meaning the left-hand side is the new standard where to specify bytes literal, and the right-hand side will no longer be supported. So basically, this is some example where we need to provide a migration tool if user want to migrate from single stage to multi-stage engine. And then also in multi-stage engine, we want to make array separate from multi-value. And then there are certain standard on array type. And also we want to introduce date, time, interval, and timestamp with time zone within the multi-stage engine. And also like the other like PostgreSQL functionalities we want to support in multi-stage engine, including like more functions, window function, and table view.
All right. With this, we probably will say goodbye to our friend Gonzalo, and we will try to bring some more people. It's an interesting platform that we're using that allows us to cap our guests. We didn't expect that there's so many great esteemed speakers here. All right, Gonzalo, thank you so much for being with us. Congratulations, we've becoming a committer and a PMC member. And onwards, like sky's the limit. There's a lot of things to do with performance. Thank you so much for your contribution.
Yeah, thank you.
And I want to thank you, Gonzalo. I want to remind speakers as we go forward, try to keep it to 1 minute per slide. I won't remind you on each slide, but just make it a good top level summary, and the recording will be available. The slides will be available for analysis for folks who want to dig into the details. Do your best. There's a lot. It's okay if we run over a little bit too. It's all right.
Okay, so we go in with the query execution with Rajat. So let me bring here Rajat, and also Jackie, you stick around because you do have some slides in the future. That would be cool, Rajat, if you will the kill your fan on top of because it creates a lot of interesting sounds in our. I'll give you a moment.
Yeah, like I'm from Bangalore. There's a heat wave going on. There's everything that's stopping me from boiling away.
Okay.
But
okay.
Let me try to turn that off. Yeah.
No, that's okay. That's okay. Continue. That's fine. Let's we don't want you to die here.
Boil away into the atmosphere. Yeah, that's
please.
Like, and that's the effect. That's
can you introduce yourself real quick and
Sure.
like what you do and why this particular topic is something that you enjoying?
Yeah, I'm Rajat. I work at Startree. I joined a few months back, and I work from Bangalore. And I work in the Pinot database team. On pagination, there have been a few requests from some of the customers on pagination, right? And there are two main reasons for this request. One is, like in a few cases, the clients of the database do not have the resources to be able to handle large data sets, so they want to break it down. And the second one is sometimes it's easier to program the client logic if the database supports pagination, right? So these are the two main reasons for why we want to implement this feature. We have a few goals while implementing this feature, right? So the first one is that a client has to only run a query once, right? So this is important for performance. We don't want to keep rerunning the query again and again to get different parts of the result set. The client should be able to move forwards and backwards, seek through the result set as it seems fit, right? And the two different paths that we can take to implement cursors. We can take the API, we can implement it using API, post/query/SQL, or we can go down the SQL path, right? And we need to figure out which way to go. I know that the LinkedIn team has an internal implementation of pagination, and I'm in touch with Jack and Sabrina who implemented their get together and see how we can kind of bring this together. Thank you.
Thank you so much. Thank you so much, Rajat. And we do have, I think we have, let me quickly add him here in just a sec. I'm probably butchering your name. How you pronounce your name? Is it Shia?
Yeah. Yep.
Yeah. Hey, welcome to the stream. Thanks. Great to have you here. Can you talk a little bit about yourself? Like, where you coming from, and like why this topic is particularly interest of you?
Yeah, so I'm Jia. I'm from LinkedIn. So I've been on LinkedIn's Pinot team for around 3-ish years. And yeah, this topic is important, I think, mostly because we've seen a lot of distinct count queries. For example, distinct on the user ID on a particular topic. And these kind of queries are generally CPU and memory intensive in its nature, because we are kind of really need to count all the distinct like IDs using some sets. So in this case, if we can leverage data partition in this query, for example, if we have 3 disjoint data partitions on the ID, and in this case we do distinct count on the ID, we can actually kind of go a short path and just for example, on each local partition, do the distinct and return the disjoint set, or just a number of the count when we are doing reduction. So the data transmission on the wire and the pressure on the broker reduction part can be reduced a lot.
Okay. Thank you so much. Thank you so much for this. We're going with the next one. And we do have Vivek. Let me bring him in. Hey, how's it going?
Hey, good morning.
Where are you coming from to us today?
So I am I'm a member of the Pinot team at LinkedIn. I've been working on this team for 2 years now. So
Sweet.
Yeah.
Great. And can you tell us a little bit about this new piece of functionality? I know like you will be covering with some other topics, but
Yes.
what's exciting about this off-heap distinct query execution?
So we've often seen that our distinct flavor queries are like count sum average can get a little expensive, because we create these in-memory sets in the heap, and this results in increased chances of it elevates our GC pressure, and particularly for high cardinality columns. So we've been playing around with an off-heap implementation for these distinct queries. We've evaluated some third-party libraries like ChronicleDB and MapDB, but what we found is we prototyped an in-house solution with only the features that we needed for an off-heap set, and that was more performant than these full-blown solutions. So what is pending from our side is to wire it into our query execution engine, but we do have a prototype where we've successfully seen that distinct queries that were usually killed by the query killing framework for consuming large amounts of heap memory now get executed for a high cardinality column. So we plan to make progress on this and release it to open source soon.
And this is where the haters of our beloved Java and JVM platforms come into play. Oh, like you have out of memories and stuff like that. Yes, we do also have access to off-heap memory, so we also can do that as well.
That's right.
Going next, I was told that Sanam were not able to join us today. We wish her well, and the Vivek will take care of it.
Yeah, so I'll be covering for Sonam. The idea here is to introduce a couple of aggregation functions that's been requested by our customers. So the first one is an any value aggregation function. Any value function, which is basically it can be used to fetch any value of a given column. And the way this would be used is it could be really useful in group by queries, where this column need not be specified as a part of one of the group by columns, and it would fetch any random value from the given column. And the second function is a homomorphic sum function. So we have some use cases here that basically store encrypted data, and they are not comfortable with having to decrypt this data at runtime and computing the sum. So homomorphic sum allows us to compute the encrypted sum of a particular column without having to decrypt it. So these are two functions that we're looking to add.
Great. Thank you. Thank you so much for this. And with this, we're going into Upsert section, and we will see if we have Rohit and Pratik. Pratik is here, and I don't see Rohit, but Vivek, thank you so much for your update. Send the good vibes to Sonam. Pratik, welcome to the show. How are you today? Where are you coming to us?
Yeah, I'm Pratik. I'm from Uber, and I've been in the Pinot team of Uber for the last 2 years. And Rohit is also there. So.
Yeah. Hey. How's it going, Rohit? Can you hear us?
Hey, hi, I can hear you.
Yeah. Awesome. Thank you so much for being with us today. Thank you so much for this awesome contribution. Can you tell us a little bit about this? Like why it is important? Like what kind of problems we're solving here?
Yeah, hi. I think the Pratik already gave our introduction. So we are both from Uber, and I think the first part is about backfilling Upsert tables. So we already have these facilities for real-time and offline tables separately, but the use case arises from the fact that we have a lot of data in our other data sets, and we quickly want to spin up a Pinot table and then do real-time analytics on it. So backfilling an Upsert table would be a great advantage over here. And the way we want to extend it is by providing externally partitioned segments, which currently is supported in real-time stream. But for batch-based backfilling of table, the support is currently not available. Uh, Secondly, yeah, I mean, there are a bunch of challenges around it for which we would want to work on it. And basically, it should also give us capability to move towards a Kappa plus architecture, wherein we can have a real-time stream of ingestion, and then we can have an offline ingestion to correct or bootstrap any data. Yeah, on to you, Pratik.
Yeah. Next, I can talk about Upsert compaction. So we at Uber are trying to productionize Upsert compaction to get disk space efficiency, and so some of the improvements which are going in and which we are planning to go contribute is one is maximize efficiency per run. So we saw that we can improve efficiency of every job run by compacting segments which have scope of higher compaction rate. Uh, Next is we have seen that over a time, upside compaction can lead to a lot of small segments in a table with very high retention. So we want to explore if we can merge multiple smaller segments for upsert and push it back to the table. This is possible for normal real-time non-upsert tables at present, but we want to continue and see if we can do it for upsert tables as well. The last 2 points are very generic improvements for minions and will definitely help us for upside compaction as well. This basically increases the interaction scope of minion nodes right now by allowing them to like process segments from even server nodes if deep store copy is missing during task execution. And also right now minion uploads the segments after processing back to controller. So if you have a lot of like task running, then controller can come under heavy pressure. So we want to explore a route where minion uploads to deep store and just ask controller to sync it to the servers via deep store itself.
This is very nice. I think this is the will help to improve kind of like interaction with the disk and making things like a faster in terms of you know doing initial restart of the cluster. Like what kind of like use case the people are seeing with this type of features?
So right now we are exploring one is infinite retention for upside tables, and with upside compaction, we feel that will be possible. We have already implemented stuff where we are removing keys from in memory, which was one of the primary bottleneck for upsides. Now we are moving on to the disk part of things where we want to get space back from disk as well.
Sweet. Thank you so much, folks. Thank you so much for this contribution, and we'll go into next one. We introducing. I
Hello.
apologize. I will be saying this wrong, but it's a Xiaobing.
That's actually very accurate.
Oh,
yes,
thank
I'm
you. Yeah, I
Xiaobing.
tried. Yes, I tried. Welcome to the show. How are you today? Where are you coming to us today?
Good,
I have.
good. So
You have a very similar background with Jackie. Are you in the same office?
yes. So now, actually, I'm joining from my basement today, and but you are right. I'm also a software from Startree, and I've been working with the team for almost 3 years now, and I'm also a Pinot committer.
And makes two of us. I'm also coming from my basement. So,
but you have a very nice. That's a real. That's
oh,
not a virtual background, right? Okay, but
100%.
mine is a virtual one. I don't want to turn it off. All right. So yeah,
Tell us
this
everything about this. Yes, it's gonna be. It
yes.
sounds awesome.
So this one is a very interesting issue for Upsert table, and so it's a consistency issue, and the consistency here is actually from the ACI, the C from this ACID term for database, and basically how to ensure the query correctness when there's a concurrent reads and writes. And today this is an issue for Upsert table because when Upsert happens and when it need to touch two segments, that operation is not atomic. So the query might see some inconsistent states if there's ongoing upsert happening like that. And one to call out is the consistency here is not about like keeping the data same across replica. That's another topic, but that's typically for like distributed systems. But as Pinot is a database as well as a database a distributed system as well. So it happened to have those two consistent issues. But for the consistent issue here is the one about the ACID. So one concrete example I show here in this figure is if we have a table with like 1 million unique case, but if you keep doing the upsert with the case, primary case from this 1 million existing case, you keep doing this upsert. Meanwhile, you do a distinct count query, and you will see like slightly overcount or undercount. And this is because this like a consistent issue, and that's the one we want to solve here. And we can try. So some solutions we think about is we can use the log to synchronize the read and the upsert threads. We can also keep like a fresh copy of those bitmaps, so we can avoid the locking between read and writes. Meanwhile, to keep a fresh view for the query threads. So that's the solution we try to explore for this issue. So, and this is about this slide. I think there's another one. So
yep,
we're going
to the next one.
Yeah. So this one is also about Upsert, and we want to like improve some performance for a couple part of the Upsert. So we know that under the hood, Upsert table need to keep a map from the primary key to the record location, so that when the Upsert need to happen, you need to find where is the previous document with the same primary key, and you need to check this map. And when we enable this Upsert for really large table, like we might need to keep like hundreds of million, even billions of entries in this map. And this map can be super big. And today is on heap, and it can start to compete the memory resource a lot with the ongoing queries and start to affect the query performance. And the second thing by having a super big map is when you want to restart the server or when you do table rebalance, the server need to rebuild this map, and it might take, you need to scan all the existing documents, which can be like around hundreds of million and billion level, and it might take minutes, even hours to finish. So it's a pretty big pain point when we want to do like server, like upgrading, those kind of things. So in Startree, we actually explored two features to solve those bottlenecks. One is we try to make this map off heap, and actually use a key value store, which can even store those key value pairs on disk if they are not really accessed very common. And another thing is we try to use meaning to pre-build the map, and which is outside the server. We pre-build the map and we put this in deep store. So when the server need to rebuild this map, it can simply download the previous snapshot we built on the meaning and try to finish the bootstrapping for this map. And one figure I put here is like, if we don't use, so before we try this, like before we have this meaning feature, like building the map without like the snapshot of pre-built by the meaning, you can see the server need to take much longer, and I actually use a lot of CPU to finish the map rebuild, to recreate the build, to recreate the map. But with the snapshot built by the Mini, as you can see on the right corner, actually finished much faster, and I use much less CPU cycles to finish the map recreation. So that's the thing we already explored and actually already deployed to some customer environment to solve the bottlenecks for the Upsert, and we are thinking about how to get the learning from this and try to contribute back to open source Pinot, so we can still try to solve the bottlenecks.
Thank you.
On the open source Pinot side.
Yeah,
that's about it.
Is awesome.
Yeah.
Like performance improvements. People always kind of like welcome this one. Thank you, Shabin. Thank you so much for all this contribution that you folks and your team are doing here in Apache Pinot. And see you on the next one. So enterprise readiness, which is a very interesting thing because when you call the thing is just like it's 101 or 1.0, it's ready for enterprise. And in order to help make this even better, I will bring back Pratik one more time. Hey, how's it going?
Yeah. So this is a very interesting feature which we are planning to contribute. So at present, tables are strictly typed to broker tenant and server tenant. And now we want to introduce minion tenant as well for tables. So what we want to do over here is we want to give users the flexibility of scheduling their minion jobs on any nodes they want. At present, it's like you just give a default pool of minion host, and all the tables in your cluster, like be it hundreds of jobs, all will run on those selected pool, and it can be randomly assigned to any node. And like you don't know which job will finish, which job is taking more resources and will staff the other jobs. So with this, you can actually isolate your table task just as you isolate your data and queries using broker and server tenant. So again, this will be a minion tenant, will be a table level config, and will also give you a task level flexibility. Like say in the first picture, if you see for table A, you want to schedule both the task in different set of nodes and not like make them overlapping. So you can override the minion tenant config at task level so that one task goes to one set of nodes and the other type of task goes to another set of nodes. And again, if you see table A and table B, among tables also you can isolate your task by specifying these configs for different instances. Yeah.
Great.
And
great. And for the next one, we have Shonak. This is someone that we haven't seen this. And also they come in from the same office. I assume it's also Startree office. How's it going, Shonak?
That's right. Yeah, I work with Startree. Yeah,
can you tell us a little bit about the database support? So why it's the check marks?
Yeah, so like we have tried to introduce the database concept in Pinot, so which basically takes us one step in the direction of making Pinot supporting multi-tenancy. So this kind of lets us to use multiple teams in an organization to leverage Pinot without the overhead of managing multiple Pinot clusters. So like each team can work with Pinot in isolation. So the things that are done here are like we now like all the table related API endpoints or controller are now database aware, so you can pass the context as an HTTP header, and based on that the isolated subset of tables will be queried on or operated on. And then we also have made the query engines compliant with this database awareness. So you can pass like the same way, like passing it as a query param or as a HTTP header to the query endpoints, and then that will allow us query a particular table in a particular database. And also like a few metrics that we used to expose as part for databases. Now they'll have a so for tables they'll have a database label as well, so that you can filter the metrics based on which database the tables belong to, and get a database level of visibility in those metrics. So
Yeah, it's pretty cool. It's we bring in more and more abstractions from the the bigger brothers, like a transactional database, like a traditional like OLTP databases. So we have a database and table. Table is not a table, right? This is just like there's an abstraction. There's a kind of like idea of the table, right? And now we bring in the database concept here and there. Thank you so much, Shunak. Thank you so much for this update. And we're going next to uh, I you're probably from Turkey, and because probably
Correct.
you go by Janer or something like that, not
Oh
the
wow, that's pretty good.
yeah, I used to work in a company called Hazelcast, and I know a few people from Turkey that we had the office in Istanbul, in Ankara. So
Nice.
there we go.
Nice. I'm used to hearing Connor, etc. But you did pretty good.
Yeah,
Thank you.
welcome.
So
Where are you
yes,
coming to us? Like, okay, we established that you from Turkey somewhere. Is it geographically Turkey, or it's just like
yes,
you're originally from there?
I'm from Turkey, but currently I'm in our Uber's Sunnyvale office. Uh,
Nice.
yes, as I said, I'm from Uber's real-time analytics team, and I've been working on Pinot related features in the last couple years. So this one, I want to go very quickly. Archival of post retention segments. This is a feature that, to a certain extent, already exists in Pinot. So we have deleted segments directory, which out of retention segments are dumped into, and then they get cleaned up on a periodic basis. So this feature is about extending and adding more functionality and customization. So the two proposed additions are ability to configure the store itself and also the directory, which directory you use, and also ability to specify pluggable archival formats. So you can export Pinot's own format, or maybe even other formats that are based on users' needs. And then some potential extensions, like natural extensions to this feature, would be restoring of these archivals, so Pinot can scale down as well as it can scale up. And also, if folks are interested, you can write readers for these archived segments. That also makes Pinot expand into categories outside of real-time analytics a little bit. So you can also reach out to offline stores and offline files. Yeah, that's it. I'm hoping other folks find this interesting, and then they can get in contact with us if they want to contribute or drive the decisions there.
Yeah, thank you so much for being with us today, and thank you that the companies like Uber allow you to work on this project and contribute your time. Thank you so much, Jenner. I'll
Cool,
hope we
thank
see
you.
you in the future. All right, and we go in next one, next topic, and we have Vivek back, and let's talk about this resource isolation for query processing, Vivek.
Hey, so the problem statement here is that we own large multi-tenant clusters with several tables and workloads sharing these clusters. And more often than not, we find that queries from one table or one workload steps on another, affecting our query performance. So what we want to provide as a part of the solution is, as a part of the end solution, is the ability to define workloads either across tables or within a table, and allocate budgets to each of these workloads. And within Pinot, the brokers and the servers, we would enforce these budgets. We would divide this budget and enforce them. And the budget enforcement can come in various forms, like CPU resources, memory disk, and IO. We plan to start off with CPU resources, but memory disk IO can be added as follow-ups. Along these lines, we have an internal implementation where the use case was that we wanted to allow access to 4,000 plus tables sharing a cluster from Jupyter notebooks, and these can be ad hoc queries fired just for testing on our production multi-tenant cluster. So just as a prototype, we did build some form of isolation between production workloads and secondary workloads. And this has helped us open up our production clusters to be queried from Jupyter notebooks, admitting them into the secondary workload query and doing a constrained processing of these queries.
Yeah, this is pretty cool. And always kind of like managing quotas and the workloads in terms of how like who can use how many CPU. It's very important. And thanks so much for working on this one. And thanks so much for being with us on this update. We go in next. We running a little bit over time because we are soon will be up to have at least like 8 to 10 minutes. And let's talk about ingestion. I'm sorry, I'm just clicking and I'm Happy to announce we have Rika here. Hello.
Hey,
I will make an assumption that you're also coming from Startree office.
no.
Okay. Okay. So that's my bad. Welcome to the show, and can you tell us a little bit about yourself?
Yeah, I'm Rekha. I work at the Pinot team at Uber. I've been there for 2 years, but this is my first year, like contributing big
And
things
thank you so much
to
for doing this.
Uber and deepen.
It's a great, like I said, it's a super when the companies allow their employees working not only on the project that will bring the value to business, but also the help to other people in open source. It's great to have you here. Tell us a little bit about the protobuf. It's probably one of my favorite serialization formats, so I always love to hear things about the protobuf.
Yeah, so at Uber, we want to start at using protobuf encoded topics along with the Avro topics. So I'm working on improving the support for protobuf in open source. So this includes utility functions to convert proto schema to Pinot table schema, and also a faster way to decode protobuf. So we wanted better speed for the ingestion to match Flink speed, which is what's being run upstream, which uses a faster way of deserializing protobuf. Protobuf deserialization can be done in two ways. One is the standard ways to use the native Java bindings compiled by the protobuf library. Using this is very fast because the code generated is optimized for the specific proto and the environment you want to like run it in. Another way is the dynamic protobuf API, which is what the Pinot decoder is using right now, which provides us a way to deserialize dynamically without knowing the proto definition before runtime. So this is known to be like 4 times slower. So we're going to, or I'm working on creating a code generation deserializer as an option for decoding, so that the decoding part of ingestion will run 4 times faster. There's a PR out now, and all the other protobuf improvements should be done by H1.
Thank you so much. And as a reminder, the slides will be shared. Folks, if you would be interested to learn about implementations, all these things you can find either in the Slack community or if you go to directly to Apache website, there would be kind of like a different the tracking options like a Jira's and all these kind of tickets where the people working on these things. If you want to continue to help and contribute, Rika, thank you so much for your time. Thank you so much for joining us. And thank you for contributing this feature. I think this is going to be awesome, and it's going to be important for many companies who use the protobuf as their kind of like a way of encoding messages.
Thank you.
Thank you. All right, we do have a next one. We have Ishik. How's it going?
Hey, Victor. Hey, it's going
Where are you
well.
coming to us?
Yeah, I'm from Startree. I have been with Startree since the last 6 months. I'm part of the data ingestion team. Yep. Okay, so here we'll do something interesting here. So this is an improvement over sorting large data sets in batch ingestion. So we already have a option to sort the columns, but for larger data sizes, what happens is that because the sorting implementation is quick sort based on the partition data, quick sort on the memory map partition data, so we face a lot of thrashing. So like this kind of supports like large scale sorting of large scale data without actually scaling up the minion. So what we'll do is do an external sorting on this, and this will kind of help us work around the issue of thrashing. So yeah.
Okay, so we're going for the next slide.
Yeah. So, okay, so here we have another interesting thing. So when we kind of, in case of certain highly compressed input file formats, for example, Parquet, what happens is like when we like decompress it, it goes like 10x or 20x on the disk. And what ends up happening is a really high disk utilization, and in certain cases, even minion failures. So, and also like this kind of affects the partitioning and sorting phase of the segment creation as well. So what we are kind of planning to do is like what the current state is, we have a naive row-based format to kind of process this in the intermediate state. what we are planning to do is like have some efficient compressed format to explore different ways to like introduce the intermediate format there. And we'll also have some ways to plug in different data format there if users wants to use their own intermediate data format and find that efficient. So yeah, that's what we're going to do.
Okay, so we go into the next one is about the scale real time to offline across
Sure.
multiple mediums. What's about?
So right now, what happens in real time to offline segments, it runs on a single minion. There is no way to kind of tune it and spread it out into multiple minions, like horizontally scale out. So there is no parameter to tune out and kind of branch out into multiple tasks. So what we're planning to do is like introduce a config max num records per task, which if we tune that, we can break it into multiple subtasks, and if the load grows, we can horizontally scale out the task. So yeah, that's what we're gonna do.
Okay, thank you so much for your time. Thanks so much for contributing this, and hope to see you in person one day.
Yeah.
Take care. All right, so we go into the next one with the indexing and storage, and the first speaker who will be talking to us is Tin Chen. Tin, welcome to the show. How are you today?
I'm very good, thank you.
Where you are coming to us?
Uber.
Nice.
After my driving. So yeah, I think I've been with Uber, and we are using Pinot for the past 5 years. And actually, we in this project we want to move Pinot towards the domain to compete like things like Splunk. We want to do log search and analytics in a lot of data. I think right now we are very happy with Pinot's kind of integration with text search library like Lucene. And this really help us to now to serve certain extent of Uber's real log search communities. But during the process, right, we do find some cases where we can improve on current text search based on Lucene's index approach. This particular feature is about spanned query optimization for substring search. In a nutshell, most of users on log search space want to do substring search. So this is an example when you see a search is a common log search requirement. It's basically people want to do a substring, which is a fragment of the sentence. So the current existing approach in Pinot today probably have left and right some issues. You can either do optimal approximation, but it's not accurate, or you need to do a very expensive log expression match. We actually contribute this feature, which utilize a lower level Lucene query feature called span query, can do both accurate and fast query processing. It can be shown in our internal environment to speed up such search in order of the magnitudes 10 times. And this is about span search improvement. Second is about still about Lucene. Actually, our team with our key member like Chris, which contribute to make Lucene index much faster by optimize the Lucene index build and to skip one iteration of doing document rescanning and rebuilding for the Lucene index. This turnout we contribute recently can save about up to 80% of index build time. For a big data source like search, this means a lot to reduce the ingestion lag. So these are the improvement we contribute, and we are going to further to refine and tune them in the open source contribution later.
Nice, thank you so much. And this is great to have this feature there in Apache Pinot. And thank you so much for your contribution. We're going next. We will speed up a little bit because we are very close to end of the hour. Thanks so much, Thin. And Chris, welcome to the show. How are you? Where are you coming to us?
Hi. I'm at home today, but in the Bay Area. I work pretty closely with Ting on the log search project, and this
Nice.
I guess this feature kind of comes out of that. So that our like motivation is I think logs generally contain like highly variable data. You don't know if you're getting a bunch of short fields or a bunch of long ones or some mixture. And we also have a lot of users that are trying to store different types of data, and they don't necessarily want to get into the Pinot internals. I think a couple of years ago, v4 forward index was added by someone from the community, and we were able to take advantage of that and better, I guess, handle that variable length data. One of the issues that we found with that was like really wide tables. Even just going onto the like query UI and doing that select star limit 10 was enough to cause some like killer intervention and crashes. So our goal has been to kind of reduce memory usage when retrieving a lot of this stored data, and do that in a way that we have, I'd say, like performance parity with v2, v3, with the eventual state being we want to be able to enable v4 by default for our users.
Thank you so much, Chris. This is all great. The indexes is the bread and butter of every database, and having the improvement in the probably, I don't know, I don't have the stats, but I would assume the forward indexes is kind of one of the most used indexes in general. So thanks so much for this contribution, and looking forward for this feature in future. We go in next with that's going to be a difficult one to pronounce, but I will try. And I apologize if I will be. Is it Q?
Yeah, I think you pronounce great. My name is Qiao Liu, and I'm also from Uber. Yeah, so today I'm going to present the project Ngram Prefix and Service Index. And yeah, the motivation of this project is to improve the query performance for the substring matching queries. And also we want to improve the QPS throughput for these kind of use cases. And there are several existing approach that we already tried, like the full scan with regex matcher and text indexes, full FST index, and native text index. And I think these kind of index are very, very powerful. However, sometimes when you have to scan a lot of rows, the index is definitely provide some of the inefficiency when we execute the query. So we have proposed some approach and do some POC at Uber. So we build this Ngram prefix suffix prefix columns, and then query with the pre-filtering on this column first, and then do the text match on the rest of the rows. So the performance that we showed is like initial result, we can get like 4x to 10x plus query performance improvement. So we are happy to contribute this feature to open source, and hope to present again later. But this is
just a quick question. Like with these type of the performance improvements, like the 4x and 10x, what's the reason behind this? Is it like a different algorithms you start using to comply with this kind of? It's a text search, right? So the things around like a full text search type of things, right?
Yeah,
if I'm understanding this correct, like what was the essence of this change that make this so much better in a upcoming feature or like upcoming the fix that will improve this?
This is a very good question. I think the query throughput improvement is based on the query latency improvement as well. And the currently, I think when we run the text match or the regex matcher on the huge data, the problem is that there are too many rows, and then it is inefficient to do the text match. However, with this feature, we pre-filtered a lot of rows. So when you do the text match or regex match to validate the final result to match exactly, then that result will become much efficiently using the text match. So it is a pre-filter based approach. And there are a lot of analysis and lessons we learned, and I'm happy to share that in a bigger form after the feature contributed.
Right. Thank you so much. This is going to be awesome. I think this is will improve lives of many the users and developers. Thank you so much for your time. Thank you so much for your contribution. And we go into another, and I think I have Jackie somewhere here. Jackie, welcome back. Thanks for sticking around with us. And let's talk about this JSON index. I would say probably it would be, I don't know, second or third most used index.
Yeah. Hi, I'm back. So actually, the following two slides, I'm here. The credit should go to like Saurabh Dubey, but unfortunately, he's not able to join us. But I don't want the community to miss this two awesome features. So the first one is, as Victor said, like JSON blob is one of the challenging problem in like analytics world, because it's very expensive to process. So here, like at Pinot, we build a special JSON index to accelerate both the filtering and the field extraction. So first for the filtering, the enhancement we did this year is, before this, we can do like JSON field match with just equality and inequality and none. And this year we have like significantly improved it by supporting the regex match and also the range query. So I can say this being super powerful now because most common use cases will be covered right now. And then the JSON extract, the initial version was actually contributed by Chris from Uber. And then we have extended it to support both the single value type and the multi-value type. And then also we have supported extra filter during the JSON field extraction. So with this, the JSON index can be used at both filtering phase and also the projection phase. And then I would imagine like majority of the use case can be supported now, and we'll keep enhancing JSON index to support more cases. Next slide, please.
Next slide. We're going into, what is that? Like, what's this?
Yeah, I'm actually a little bit surprised it's not introduced by Uber, but this CLP encoding is like actually contributed by Uber to serve their log analytics use case. And then the improvement we made here is we modeled it as a standard compression codec for forward index. In order to use it, like initially, a lot of like user-defined function need to be, I would say like there's a very special use pattern in order to use it. So basically we simplify that by directly modeling it as a forward index compression. And then right now, in order to enable it, just simply specify the compression codec within the field forward index config as CLP. And then it will get most of the power from it. Basically, you get very good compression. You can still retrieve the original log. That's about it.
Sweet. Yeah. Thank you so much, Jackie. Thank you so much for being here. Thank you so much for talking about all these things. And next one, my friend is from East Coast, Eric. Great to see you here.
Nice to see you, Victor. Yeah, I'm Eric. I'm with Startree, and I'm presenting on this new data type feature that we're adding, which is a map type. Our motivation here is to have better support for semi-structured data and like key value pair type data, specifically geared around allowing us to have both a better user experience so that you don't have to write like JSON extract for everything or JSON paths. You can just reference it like you might with a regular map type in a query language or programming language. And then to also allow us to build more efficient, more optimized data structures underneath, indexes underneath, so that the performance both for storage and query is better than when we're using just, say, extracting from just raw JSON, and storage performance is better than if you, say, use complex type to expand and flatten your maps. And the long-term goal, like right now we support one-level deep maps, and then the long-term goal is to support things like nesting and more complex semi-structured data.
And that's super cool.
That's it.
Yeah, thank you so much. Thank you so much for this update, Eric, and looking forward for this contribution. All right, so I have a few more slides to finish up. I'm extremely grateful and extremely humbled to be among all these incredible community members and the commuters and PMC members, everyone who make the success of Apache Pinot happy. And on top of this, we at the Startree, developer advocacy team works very hard in order to make certain things easier for people to understand, easier for people to learn about this. One of the things that we actually working closely, I would just like to do few minutes, few seconds before we part. But we start building these Pinot recipes. This is the project on the GitHub. You can go and start playing around with this. My colleague and friend Hubert, one of the developer advocates here in StarTree team, he going through this like super super task, going through all the recipes and making sure they are working with the latest and greatest release. We're showcasing some of the new features. Go check it out. We do have a vector index recipe, some Gen AI use case. This is super cool. If you wanna see more, come to our booth at Real Time Analytics Summit next week. And also, if you want to join us for some events nearby you, we do have a calendar of all the things: meetups, conferences, some of the any type of speaking engagement that happens in your town. I hope I'll see many of you there. Please bookmark this the calendar, and we'll see you in person. And I think with this, we would skip the Q&A because of time, but I promise you, I will make sure that we will either organize another kind of like another event or another stream where we will be talking about and answering all these questions. Plus, this video will be available from everywhere. It will be on YouTube, on LinkedIn. You can go and ask questions with the speakers, engage after this. Also, Slack. Don't forget to join Slack, ask questions in Slack. Troubleshooting, probably my favorite place to get inspiration about new things about Pinot, and also learn how the people are using Pinot. And also, we do have like a lot of materials for people who just started. Again, I would like to say thank you for people who helped organize it. On behalf of our Jordan Rokach, thank you so much for making this happen and like bring everyone together. And with this, as always, my name is Victor Gamov, and I wish you a great day.